Hello. So this is a compass. You should find a compass in your box in week 14 on magnetism, and it's a regular compass. It'll point north. North is the direction you're looking. So if I get this magnet far away and take a look at it, and you can see that it is north, is pointing this way, which is north. Okay, at this location. All right. So we can use this compass to measure the magnetic field of a magnet, and this is a permanent magnet. I taped it down so it won't move, but I will untape it and then retape it in place. This is a permanent magnet. It's made out of rare earths from the periodic table. You can look them up on the periodic table. And this is the north side, so I can put an N there if I wanted to, and this is the south side. And so I'll put it down. Oops. I'm using, oops. I want to just tape it so it doesn't move. And okay, so there you go. So now I've already done these blue arrows, and but it should be the same on the other side. But let's just check and see. So suppose we put this compass right here. And you can see the north is pointing this way. That's north. That's south. So you just put the compass anywhere you want, anywhere in this field, and then move it aside and draw the arrow. Okay, that's the arrow. That's what the magnetic field is like at this location. Because what it does is the compass aligns itself with the local magnetic field. So this is a north. Oops, see, there's iron in this pen, so it attracts to the magnet. So the North Pole will always point in the direction of the magnetic field. So let's put it out here. So now the North Pole is pointing, whoops, let me get things out of the way here. The North Pole is pointing this way. So at this location, I'll just move it aside, it's like that. And if we put it out here, north looks like that. Okay? And put it here. North looks like it's pointing here, so here it is. Okay, so we can just north is pointing this way. Okay, so I did a lot more here, and I'd like you to do this actually on a plain piece of paper. In your notebook would be fine, but the notebook doesn't sit very flat. But in any case, this is the local position of the magnetic field everywhere, and I did many more here. And then you can draw magnetic field lines. So this magnetic field line looks to me like it goes like this, and goes around to here, right? Sure enough, it does. And there's another one that does this, and there's one that does this, okay? And that is a dipole. Here's the direction of the magnetic field, pointing in this direction. I'll put arrows on it. And so that is a dipole field. It's a dipole field. It has a north pole here, and the magnetic flux lines leave the North Pole. Whoops. They leave the North Pole, go out and around, and come back to the South Pole. All of them do that. They don't end anywhere else. They end right on the South Pole. So that's a dipole magnet. Now, as we saw in the recorded, as we saw earlier, there is something inside the core of the Earth that makes a dipole field. So the magnetic field of the Earth is a dipole field. And if you're to draw it to scale, you know, this might be about the size of the Earth. This might be about the size of the Earth compared to the shape of the dipole field. And so what's inside of the Earth generating this is actually not truly known, although you can make a lot of good guesses. Okay, so next we will then look at making a motor.